Welcome MA3 community. In this video we want to talk about the handling of complex fixture types in MA3. As an example, we will show how we work with the Mac Aura XIP or the Color Strike M in order to get a good and flexible control of all their features, for example to build beautiful intensity FX with their pixels. In order to get there, we will cover three aspects in this video. One aspect is the grouping of those complex fixture types, because this is a crucial point in order to get good control over all the different features. Another aspect is the work with the selection grid, because this is essential to get good looking FX and represent your pixels correctly with regard to your real stage layout. And for sure, we will also give you some general tips and tricks with regard to the fixture handling in MA3 when it comes to those tree structures of different subfixtures. So let's jump right into it. The first fixture we check out in detail is the Color Strike M. Probably a lot of you guys out there know this fixture type quite well. In the video, we use the 97 channel mode, so the biggest one, which would be also our recommendation for full flexibility. The fixture itself comes with different elements, for example, those RGB pixels on the outside of this plate and some strobe lines in the center. And then we have for sure the main body with tilt control of the entire plate. So when it comes to those fixture types where we have multiple different elements integrated into one physical fixture, there's one basic approach which I think works every time and is quite easy to understand. And there's no big magic behind it. It's simply treat this fixture as multiple ones and split this into different fixtures for your mind and for your grouping concept in MA3. So from now on, we will separate it into two different fixtures. My first fixture, type 1, has the main purpose of those RGB pixels and the tilt body control. So it's basically some kind of a wash moving light without a pan control. And the second type is simply a strobe. So I have only this strobe line in the center, which lives in this virtual second fixture type. Once we have understood this basic approach, it is time to bring it into MA3. And this is the point where our grouping concept comes in place, because for sure we have to separate all those elements also for the MA3 software in order to be flexible in terms of FX for those different RGB pixels or our maybe tilt movements that we want to create. Okay, so let's switch to the MA3 software and do this together. The first thing you should take care of in MA3 is to find well-built fixture profiles for the fixture types you're planning to use. For sure, good fixture profiles are always important, but especially when working with complex fixture types where we have a lot of different subfixture layers, things can get really messy when working with poorly built fixture profiles. So make sure to start right here. So let's look for a proper built Color Strike M fixture profile. And in order to do so, we would always recommend to use the online search as well. And our experience here is that over the last month, in the most scenarios, the manufacturer online profile, which you can recognize by this little factory icon up there, is probably the best starting point you will get if you're working with a fixture type where you do not have, let's say, a confirmed fixture profile or maybe a self-built fixture profile that works quite fine or maybe a friend of yours is using. Okay, so I will simply patch my fixtures according to my rig. And we will speed the section up a little bit because I think this is a quite boring part for you. Okay, so we are done in the patch menu. I have entered some fixture IDs and the patch is set up and correct. So we can leave this and save it. After you've patched your fixtures, make sure to check your fixture sheet in order to understand the structure of your fixture profile. This is really crucial to work with it. So let's have a closer look here. With the fixture profile we are using, we will find a 3-level structure in our fixture sheet for the Color Strike M. The top level in here are your main fixtures for the color strike M. So fixture ID 1101 or 1102. They are also highlighted in green. So this is, let's say, your overall master for the fixture. Below this top level, you will find two subfixtures called plate and beam in here, which represent your RGB pixel and your strobe pixel masters. So they are some kind of sub-masters for your entire RGB or strobe pixels. Just the naming is a bit different here. And this is already a very good indicator that this fixture profile seems to be really well structured, because you get a direct separation of the next elements on your logical next level below your master. This second level structure is also represented in the fixture ID of MA3 with the dot syntax. So you can see that with .1 or .2 in the fixture ID, you can select the corresponding sub-elements of the color strike M main fixture with fixture ID 1101. In our third and last level of our fixture structure, we will then finally find our pixels. So the individual control for all pixels of the color strike M. For the strobe, we have a total of 28 pixels, and for the RGB, we have a total of 14 pixels. We can also count this here, by the way. So 1, 2, 3, 4, 5, 6, 7, and so on. So 2 by 7 is 14. This can also be seen in here, where we find a representation of those 14 pixels directly on our third level also with the fixture ID. To sum it up, make sure that you get a good fixture structure in your fixture sheet with the fixture profile you are using, and that you understand this tree structure that you will find in MA3, for example, for a color strike M. It is really important that you understand which level is responsible for what, and how this is related to your physical fixture. So always make sure to check your fixture structure. After that, we can focus on our groups. And in order to do that, the first thing we want to do is we check the placement of our fixtures in the actual stage layout. In this example, for the color strike M, we have a grid of 2 by 8 of them here at this wall. And so this is the arrangement we want to consider and reflect in our selection grid for the groups in MA3. I usually start with the top level of my fixture profile tree structure. So the first thing I want to do, I want to put those main fixtures in. And in my fixture ID scheme, I have 1101 through 1108 for my first row, and 1201 through 1208 for my second row. And I will simply store this to my main fixture for the color strike M as a group. Then we continue with the second level of our tree structure of the fixture profile, so our submasters for the RGB and strobe pixels, which are called plate and beam in here. To select them, I now need this dot syntax, so I clear my programmer and enter 1101 through 1108.1 to get the first row of my submasters for the RGB pixels, and then 1201 through 1208.1 to get my second row of them. And then I simply store them in another group. We directly continue with our submasters for the strobe, so 1101 through 1108.2 for the first row, and 1201 through 1208.2 for my second row. After this is done, we can focus on the pixel itself. Before we store the groups, make sure that you understand how all those fixture IDs or the individual pixels are arranged within the physical fixture. So I have copied an image here from the manual. You normally find this information in the manual or the DMX info sheet from a fixture, to simply check the pixel arrangement. And we can see that we have 2 rows simply enumerated from 1 to 7 and 8 to 14 for the RGB pixels, and the same but with 28 pixels in total for the strobe pixels in the center of this fixture. After we've checked the pixel arrangement, we could now simply calculate the total pixel count of our stage layout and enter it manually into our selection grid using fixture ID commands and so on. But the good news here is that in MA3 we have a way better workflow provided by the system. To make use of it, the first thing we want to do is to select one of our submasters for the RGB pixels. I simply do this by clicking into this fixture sheet. After we have done this, we use the down key, which is a hardware key. You can also find it there, and I have simply put it here using the quickies to get the level beneath it. So the single pixels for the RGB cells of our color strike M only for one fixture. This is the important point here. Then we have to arrange those pixels in here until we get the correct representation of our pixels according to our manual. So in order to do that here, I think we can use a short trick because all the pixels are in there, but they are not divided or separated into two rows. So in order to get that, I think we can use the flip command and then this one and flip it back. To get this representation. And if you remember the picture from the manual, we have now our correct representation of those pixels, starting with pixel number 1 to 7 for our first row, and continuing with 8 to 14 in our second row. After we've achieved this correct representation of the pixels, we use the command GridStore. And this allows us to store this arrangement for the sub-fixtures from the selection grid into the fixture profile so that the MA3 system knows how the sub-pixels or fixtures should be arranged when using them in the selection grid. In order to get a selection with all our pixels for the entire rig or stage layout, we now clear the programmer, select the submasters for the RGB pixels, which already have a correct representation of the stage layout, so our 2x8 grid of the wall. And then we can simply use the down key because this will give us a perfect representation for all the pixels now after using the GridStore command in MA3. And I think this is the best and most structured way to organize pixels in MA3, especially when it comes to more complex scenarios like we will see it later on in this video with the Mac Aura XIP. Okay, so we simply store this group and this selection. Let's call this pixels RGB. And then we continue with the strobe pixels in the exact same way. After clearing the programmer, we again select one of those submaster fixtures, this time for our strobe pixels. Then we use the down key to get all of those pixels below it. And last time for the RGB pixel, we used those grid tools. This time I show you another way. You could also simply use some fixture IDs here to get this separated. So we use 1101.2.15, which is the first one, through 28, which is the last one. And I have selected this, which you can see indicated by the blue marker, so this field in the selection grid. And if I now hit enter, it will put this selected fixture ID range there, so I get also the same nice separation. After that, we again use GridStore. So I have to deactivate my shortcuts here. And we save this arrangement to the fixture type. Then, as you already know, we can clear our programmer, select all our submaster fixtures, use the down key to get the cool representation of all the pixels for our rig. And we will store this as another group called pixels strobe, and we clear our programmer. At this point of the video, where we have set up our groups for all the different elements or levels of our fixture type, let's have another look at our tree structure and do a quick wrap up. In our tree structure, we find 5 elements. we have our main fixture, we have our two subfixtures or submasters for RGB and strobe, and then we have the pixels for RGB and strobe itself. And that's exactly what we have now put into MA3 using the selection grid for the correct representation of your stage layout and storing it into corresponding groups. And in our opinion, this is exactly what you need to work with complex fixture types in order to get the full flexibility and the most out of those amazing fixtures. Before you start working with those newly stored groups, I highly recommend to check them and use the highlight key in combination with next to just go through all of them and simply check if they work correctly and if your arrangement is really correct that you've put in the selection grid. A good tip here is to use set and the transpose function of the grid in order to check also the other dimension, because with next you can simply move along the x-axis of your selection grid. So there's no way to easily move along the y-axis, and therefore it makes sense to use transpose after using set to change this. And as you can see in Capture, I can go through my two axes of the selection grid in that way very easily. In that pattern, I continue for the other groups just to see if they work fine. Yep, this looks good. Also quite fine. And then we come to the pixels. Here you might experience that selecting the pixels and using highlight is probably not enough to get out intensity from those fixtures, as you can also see here in Capture. And this is the point where we have to start thinking about some basic intensity structures of those fixture profiles. If we check the fixture sheet, we can already see that we have some dimmer issues here, because what we can see there is that we have maximum dimmer values for the selected pixels, because we use highlight, so that makes sense. But we have no intensity values, so a dimmer minimum for our next level above, so our submasters, plate and beam, also for our strobe pixels, and also for the main fixture of our color strike M. So at this point, we need some kind of concept that defines which level of a fixture should be in control of intensity values. And in our way of thinking, we always want to have the pixels full control of the intensity values, because this gives us full flexibility. In order to achieve this here, we need to change some default settings. And therefore, we take a look at our tree structure where we only want to have those pixels here down below in control of intensity values. And this means that we want the main fixture at a default on state and also our submasters at a default on state. Only the pixels itself should be at a default off state so that we have the full control over intensity output by them. To get this in MA3, we select the levels of the fixture that we want to have on default intensity on. So we select the main fixture, our submasters for RGB and strobe. Then we simply use add or add 100 to bring them at full intensity. And after that, we enter the store default keyword. And this will allow us to store those new maximum intensity values as default. Here we can confirm using merge, but it doesn't really matter. I think override should also be fine. Then we directly continue after clearing our programmer with the pixels where we want inverse behavior. So we select them and use ... or add 0 to bring them at the lowest intensity level. After that, we again use the store default command and confirm using merge and clear our programmer. After that, we are set and done, and we should see this new intensity structure also in the fixture sheet. So let's check a color strike M in detail. And as we can see here right now, we get minimum intensity values for our pixels and maximum intensity values for our submasters or our main fixture. And we can also see this now in the highlight behavior. Because if I activate highlight right now and select my pixels, I will directly get a light output here. And this is also the stage where we can check our selection grid for the pixels. And for sure, this also works for our strobe pixels. So this is the point that you want to achieve here with a good intensity structure of your groups, at least in our way of understanding and our way of operating. For the operating, you now have to decide which elements or which group you need to build the FX or the look you want. In our template show file that we are offering, we have a strict concept here, which I will show here as an example and also for the users out there running our show file. Our concept consists of different groups which are there to separate different fixtures, fixture categories, fixture types, or clusters of fixtures that should do the same in your show or that you would like to treat as a unit in your show file. And that's the point where our separation of the RGB and strobe pixels comes in place here. So if you remember this slide from the beginning, in our example, we want separate control for our RGB pixels plus tilt body and our strobe elements. To achieve this, I will store our RGB pixels to our group A Symmetric A, which is the main group for intensity and color control in our show file. It is used in several recipes of the show file, and I will also show this later. Then I will put the rest of the remaining elements above my RGB pixels to another group called Pixel Master in our show file. Therefore, I select my main fixtures and then I use my cursor in the selection grid, hit the upper left corner again and select the submasters as well. Then I get this result in the selection grid where I can see that they have the same placement. So in terms of the location in your grid, the main fixture and the submasters for the RGB are now the same. And that's what I want to achieve here. After this is done, I hit store and store my pixel master group. This is the group which is used for other attributes in the show file, for example, strobe channel control or movements if we work with complex fixture types. Then I continue in this pattern for my next fixture category that I want to use separately, and those are my strobe pixels, which I store to a group B, and my submasters for the strobe, which I use in the group B pixel master group. And after this is done and the show file is set up, you can create beautiful FX and control those fixtures really versatile in terms of their different features and attributes. For example, I can create some beautiful looking intensity FX using this group that we've created with the correct pixel placement regarding our stage layout. So for example, this sequence here is just applying an intensity FX to these groups using MA3 recipes. We can also check this by using the edit command and hitting it. And as you see, this is our IFX5 sequence for group A, and it's applying this relative dim sign FX to our group A Symmetric A, which is our RGB pixel group. And in comparison to our intensity FX, where we use those individual pixels, we need those groups where we have the submasters or masters, for example, for optics or positions, or even movement FX. I can show you, for example, this with our tilt sign on those color strike M. And if I simply open this sequence, we can see that we're using the pixel master group here, which also contains the tilt attributes or the control for the tilt attributes of our color strike. And that's the basic point here, why it is so important to get well-structured groups when working with those complex fixture types. So as I have just shown, you have to think carefully about which group is used for what. And if you are a user of our show file, you can set this or define this in the show file menu. Here, we provide a bunch of macros that allow you to easily swap the groups that are used in the recipes of the show file according to different attributes like positions, strobe, or other optics elements of a fixture. Those macros are available for all the different fixture categories in the show file. And with our color strike M, we want to ensure that we use the pixel master groups that we've set up for the position attributes and our strobe attributes, because they are located in that group and not in the pixels itself. And for our SHOWFILE users out there, please also note that you can skip the step of setting up the intensity structure, because the dim default macro in here does the exact same thing that I have done manually. So instead of storing those intensity values to get a good intensity structure, you can simply store the groups, so the symmetric and the pixel master group, and afterwards hit dim default. So there's no need to set this up manually. Simply put the pixels in here, like I did, and the rest of your fixture in your pixel master groups and hit this macro. Then this is done automatically, no need to do this manually. Okay, so after we've set up our color strike M successfully, let's continue with our Mac Aura XIP. And therefore we do a quick check of our stage layout. And as you can see here with those blue fixtures, we have the basic same setup with 8 fixtures in 2 rows. And for our Mac Aura XIP, we are also using the fixture profiles that are provided online by the manufacturer. And in this example, we're going for this ludicrous mode with 93 channels. So I will now patch those fixture types, and then we start working with our groups. After we have patched them, the first thing we want to do is that we check the structure of our fixture type. I've explained this in more detail with the color strike M, and I will now be a bit faster on this point just to save some time in the video, and therefore we are only doing this checkup here in MA3. What we can see here is basically a structure very similar to the color strike M, because we also have 3 levels in total. So we have our Mac Aura XIP main fixture, then we have our 2 subfixtures, 2 submasters for the beam pixels and the aura pixels, and underneath those 2 subfixtures we will find the individual pixels. So 7 for the beam, as we can see here, and a total of 12 for the aura. After we have an understanding of our fixture structure, we can again start storing our groups. For the main fixture, I will simply enter my IDs, so 3101 through 3108 will give me my first row, 3201 through 3208 will give me my second row, and I will store this as my main fixture group. I will directly continue in this pattern for my submasters of the beam, so 3101 through 3108.1 will give me my first row for the beams, and 3201 through 3208.1 gives me my second row, and I will store this here as my submaster group for the beam pixels. Then we simply repeat this step for our submasters of the aura pixels. So clear the programmer 3101 through 3108.2 in this case, and then directly continue with 3201 through 3208.2 for the second row, and we can store this there. Now we are again at the point where we need our GridStore command to arrange the individual pixels, and therefore we select first one individual submaster for our beams. So let's simply clear the programmer and select this one. After that we use again the down key, and we get the arrangement of the individual pixels as it is initially stored in the fixture profile we are using. Let's quickly switch to a bigger selection grid and compare this with this pixel arrangement information that we can find in the manual. Okay, so this doesn't look too bad, but I think it's somehow mirrored. 7 is up in the left corner and we have it down on this right corner, and I think we should be able to fix this simply using those mirror commands here. So we do a mirror on the x-axis and a mirror on our y-axis, and I think, Yeah, this has fixed the issue. So we are now having the same representation like we have in the manual when the fixture is mounted at a truss, so not standing on the floor. At this point, we enter our GridStore command, confirm this, and switch back to our groups. We directly repeat this step for our Aura pixels. Therefore, we clear the programmer, select one of the Aura submasters, use the down key to get all of them in place, and switch back to our big selection grid to arrange them. Because as you can see here, for the Aura pixels, there is no initial representation at all stored into this fixture profile. So this will be a bit more effort now to fix this. For this job, the setup function of the selection grid comes in really handy, because with this you can arrange elements in the selection grid freely. And this is what I want to do now. I will simply try to recreate the arrangement shown in the manual in the selection grid. And while I'm doing this, we will speed up the video a bit until I get a good result. Okay, so this is my result in the selection grid after some work. And if we compare this to the pixel arrangement shown in the manual, I think this looks quite fine and we can work with that. Before we use our GridStore command, make sure to leave the setup mode and use the remove offset command, which you can find here in the toolbar. This ensures that your entire arrangement in the selection grid is placed at the correct starting or reference point for the X and Y axis, which should always be 0. After this is done, we can use GridStore again, and we confirm this and move back to our groups. Here we can now use our sub master selection with a down key to get a cool representation of all our individual pixels. And here you can see the beauty of this GridStore workflow, because it would be really hard to get all those pixels in that cool order manually. We store this as a group and call it pixels beam, and continue directly with our Aura pixels in the same way and store this in a group called pixels Aura. And we are done with that. As explained in the section of the color strike M for our template show file, I have to put those groups now correctly into our operating groups, which are used in the recipes of our file. My third fixture category in the show file should be in control of my beam pixels and the overall basement control, so my basic wash moving light. In order to achieve this, I will store all my pixels in my corresponding SUMRIC group, and then I will store my main fixtures together with my submasters for the beam pixels in my pixel master group. Here I have to do the same trick. I will select again this point here in my selection grid and also put in the sub beam masters there. Then I can store this as my pixel master group. Then I continue basically in the same pattern for my group or category number 4, where I want to have control of all the Aura pixels. So I will store my Aura pixels in this corresponding SUMRIC group and my submasters for the Aura pixels in that pixel master group there. After this is done, we can clear the programmer and check our intensity structure. As we can see here, the dimmer is closed for the submasters and it is open for the pixels, and that's the point where store default comes in place, as I've shown it in detail with the color strike M. To fix this, use the manual workflow that I've shown with the color strike M, or if you're using our template SHOWFILE, simply switch to the SHOWFILE menu and hit the dim default macro both for your beam and aura section. So I will hit it there and I will hit it here. After that, we can check the result. Now our dimmers for the submasters beam and aura aren't closed anymore. And for the individual pixels, we get dimmer values of 0. And that's what we want here. With the experience from the color strike M, we should now be at a state where we can start using those groups. But unfortunately, this isn't the case. Because if we look into Capture, we can see that we have light output for all the Mag Aura XIP, even if we have closed dimmers and 0 values for all the individual pixels. This behavior is caused by the combination of our open dimmer values for the main fixture and the submasters of the beam and auras together with active color values, so max values for RGB of those submasters. That those color values here will become an issue can also be seen in the manual of the Mag Aura XIP. Here we find the following information, and this basically says that our global aura RGB channels, which are here on DMX footprint ID 30, 31 and 32, are always added to our individual pixels, starting at DMX footprint ID 58 of our fixture using HTP. So the highest value will always win, and for sure this is an issue if we want the individual pixels to be in control of both intensities and color values. The intensity structure is already fine, as we have fixed this using store default for the dimmers, but now we have to repeat this procedure also for the color values here. So let's do this real quick. In order to do this, we select the corresponding groups we want at RGB values of 0, so our main fixtures and both submasters, so our level 2 fixtures. And then we go to the color section, enter 0 values for all of our 3 color channels, and use again store default. We say merge, this is fine, and we can clear our program afterwards. If we check our stage in Capture or our fixtures in the fixture sheet, we can see that we get a different result now. And as expected, our RGB values for the submasters are now at minimum values, and that's the thing we want. And as a result, we also get a black stage, so no light output for those fixtures. And as a last step to verify that everything works fine, always check your pixels using highlight. And in my case, I'm not getting the result I've expected because highlight is giving me black pixels and I have no light output. So let's also fix this. This is not a big deal because it's probably only related to wrong highlight values. You can check the highlight values in the fixture type. So navigate to fixture types, identify the fixture type that you're using. So the Mag Aura XIP, go to edit, go to the corresponding mode, go to edit again, and check the highlight values in here. And as expected, we have 0 values for highlight for our pixel dimmers and our RGB values. And that's the problem as expected. So we can fix this directly in here or use the highlight store command. And that's what I'm going to do now. So I can close this and do this using a command. Therefore, we define the highlight values we want in the programmer. So I go for a dimmer value of 100 and color values of 100. And as you can already see, maybe in Capture, this gives us direct light output. After this, I enter the command store highlight. I say merge, but it doesn't really matter in this scenario, I think. And I can clear my programmer afterwards. After this is done, I can select my pixels and I will directly get a light output, as we can see in Capture, using highlight. And I can now sweep through my x-axis using the next key. And as expected, I get a perfect control of each individual pixel in the correct orientation or arrangement according to my stage layout. After this is done for the beam pixels, make sure to repeat this process with the aura pixels if necessary. So also make sure that you can use highlight here and check your pixels. To show you some examples in the video, I have completed the setup steps of our template show file in the background. So I have created some presets and so on. And I get now the full control of my beam and aura section. For example, I can apply maybe a dimmer FX on my beam pixels, so the main pixels of this wash fixture, and as you can see in Capture, this works just fine. For sure, the same applies to the aura, so I can activate the aura and also apply some FX here. Along with the operating of those different pixels, I have another tip for you. And this tip is simply play around with the selection grids. At the moment, we have set up our groups to always represent the stage layout. And this makes sense and can create really cool FX. But there are also other selections that can make sense. One selection I would definitely recommend is the selection I normally call single fixture usage. The reason for that name is simple. I have aggregated all the single pixels of individual fixture at the same place in my selection grid. And this gives me control like with a normal wash moving light without any pixels. So this can be really cool when working with FX or when working with bumps where you don't want pixel separation. And it's a really easy way because the only thing you have to do is to change the group you are using in maybe your recipes for the bumps or your FX and so on. Another interesting selection is the one I normally call single pixel usage. Here I have aggregated all my pixels for all the fixtures at only one correct pixel representation for all my fixtures. So this results in FX or bumps that are applied to all my fixtures in the same way. So I have no spread along different fixtures, but I have a spread along my pixels. For sure, I will also show you some examples, and for our SHOWFILE users, keep in mind that this is a perfect usage for the Symrig B groups. So you can use them to get a different selection grid here to easily change your FX and so on without the need of adapting MA3 elements. In this example, I am using this dimmer sine FX together with my beam pixels, and it is now applied to my Symrig group A, so to the selection where I have the pixels spread over the entire stage layout. And what you can see here in Capture is that this works just fine. And if I switch the group that is used by using our FX Setter plugin to Symrig B, we get a different behavior. And we now have the same pixel FX for all of our fixtures. And this is a really cool way to change your FX quickly and to create different looks. In the second example, I'm using this intensity step FX for the beam pixels, which results in this interesting looking pattern. And if I now want to apply this step FX to the entire fixture without individual pixels, I can also realize this by simply switching to a different group selection. And I will do this now also using our FX setter. And in the background, I have changed my Symrig group B to the group that I've called single fixture usage, where I have all the pixels for one fixture in one place at my selection grid. And in Capture, you can already see the result. I get a normal chaser using the entire fixture without individual pixel control. So as you can see, you get a really high flexibility with this approach using different selections in recipe lines. So we can only highly recommend this workflow to you because this is a very powerful tool in MA3, and we have successfully mastered the Mac Aura XIP with that. For the end of this video, we will have a look at the Colorado pixel curve, which is a fixture that looks really complex, but it's much easier than you think and much easier than those two other fixtures. So let's do a quick run here. First, I will patch my fixtures as always, starting with the manufacturer profile, and I'm using this full pixel mode with 169 channels. Then I will quickly create my group for the main fixture, and as you can see here in Capture, we have a total amount of 14 fixtures, so 2 rows with 7 fixtures each. Then I do a quick check of my fixture structure. Here we will find only 2 levels, so I have my main fixture, and underneath I have my 12 individual heads that I can control, and this will be my next group, and then we are basically done with the grouping here. As we have a really simple alignment of those heads, so only a linear alignment, we can probably directly use the down key. So we can check this really quick, move to one of those fixtures, press down, and yeah, we got them in correctly, starting from 1, ending up by 12. So I will clear my programmer, select my main fixtures, use the down key, store this as a group, which I call single heads. And that's basically it. And as you already know, the next step after setting up those groups is to check your intensity structure, or also look maybe for some color values that are not perfectly in place. So we will check this, and as we can see here, we have the dimmers for all the individual heads at 100%. So that's a thing we want to fix real quick using store default. I have selected all my individual heads in the background. I set their dimmer to 0, and I enter the corresponding store default command, confirm using merge, and there we go. This looks quite good. We have the dimmers now at 0. And after that, we should be able to check this single head group. Unfortunately, we are also experiencing a highlight issue with this fixture profile. So as you can see, highlight won't give me any light output on stage. And therefore, I will now fix this real quick and set new highlight values. In this case, we have some more values to fix. I have checked this in the fixture profile, and highlight is giving us wrong values for the dimmer and also for our shutter, which is not open, but we want the shutter to be open for sure if we use highlight. So after we've set the shutter to open and the dimmer to 100, we can use store highlight and confirm this using merge. Now everything should work fine when using highlight, and as you can see here, after selecting my group, we are getting light output, and I can check the individual pixels, and yeah, my representation in the selection grid of those individual heads is just fine. I will now store those groups to my operating groups from our template show file, as I've also done it with the Color Strike M and the Mac Aura XIP. The individual single heads will for sure become my symmetric group for full flexibility, and the main fixture will be there as pixel master. The funny thing about this Colorado pixel curve is that you get individual heads integrated into one physical main fixture, but all the individual heads have full control of their attributes. So I have individual tilt control for each head, I have individual beam, so for example strobe and shutter control for each head, and also individual zoom control for each head. So in terms of operating, this makes life really easy because I do not need these main fixtures for basic functions. Maybe I need it to reset my fixture, so using the control channel, but for operating, I should be fine only using the individual heads, so my subfixtures itself. For our SHOWFILE users out there, this means that you do not have to use our macros here to switch to the pixel master groups in some recipes, because all the control should be done by using our main symmetric groups. And after you've set up your show file, you can play around with those individual heads and create interesting looks. For example, when using this intensity FX or applying a tilt sweep on them, which is really interesting and funny because this will result in those interesting looking wave shapes as we have the individual tilt control for each head. So, as you have seen, sometimes fixtures are easier than you think, and this is definitely the case for those Colorado pixel curves because in the end they're just individual moving lights. And with that, we would like to end this video and thank you for your support. If you liked our new tips and tricks video format, please subscribe to our channel so you don't miss any new videos. And let us know in the comments what topic you would like to see here next. Thanks for watching and stay tuned.